Hello everyone, my name is Parmida Heydari. Today we are going to learn Kubernetes storage. When a container crashes, container state is not safe, so all data will be lost. Kubelet restart a container with a clean state. Kubernetes volume abstraction solves these problems. Kubernetes provides several types of volumes. Let's take a look at some of them. Config map provides a way to inject configuration data into pods. The data stored in a config map can be referenced in a volume. Here there is an example. We have a volume named config-val, and by volume mounts, we mount a specific path. Another types of volumes is downward API. The downward API in Kubernetes provides a way for containers to access metadata about themselves and their environment without needing to interact with Kubernetes API server. The downward API allows containers to access various fields from the pod specification, including pod name, namespace, unique ID, IP address. Empty dir. For a pod that defines an empty dir volumes, the volume is created when the pod is assigned to a node. All containers in the pod can read and write the same files in the empty dir volume. When a pod removed from a node for any reason, the data in the empty dir is deleted permanently. The empty dir volume types in Kubernetes is used for temporary storage that exists only for the lifespan of a pod, making it ideal for scenarios like caching. Fiber channel volume type in Kubernetes allows you to mount existing fiber channel block storage volume into your pods. These types of storage is commonly used in enterprise environment due to high performance and reliability. The host path volume type in Kubernetes allows you to mount a file or directory from the host node's file system into a pod, enabling access to host resources directly from your container. This is useful for scenarios where pods need to interact with specific files or directories on your host. One common use case are monitoring and logging. What is PV and PVC in Kubernetes? A PV, persistent volume, is a piece of storage in the cluster that has been provisioned statically or dynamically by a storage class. A PVC, persistent volume claim, is the request for PVs. Pods consume node resources while PVCs consume PV resources. PVs are resources in the cluster while PVCs are requests for those resources and also act as claim checks to the resources. Notice if a user deletes a PVC in active use by pods, the PVC is not removed. PVC removal is postponed until the PVC is no longer actively used by any pods. Also, if you delete a PV that is bound to a PVC, the PV is not removed. PV removal is postponed until the PV is no longer bound to a PVC. The lifecycle of persistent volumes in Kubernetes consists of 4 main stages: provisioning, binding, using, and reclaiming. Provisioning. There are 2 ways of provisioning, static or dynamic. PVs can be provisioned static or dynamic by a storage class. In dynamic provisioning, the Kubernetes cluster automatically creates a PV that meets the specification of the PVC. Binding. When a PVC requests the storage, Kubernetes binds it to the available PV that meets its criteria. A PV can only be bound to one PVC at a time. This binding process can happen automatically during dynamic provisioning. Using. Once a PV is bound to a PVC, it can be used by a pod. The volume is mounted into the pod's file system. Reclaiming. After a PVC is deleted, the PV enters to the reclaiming phase. The reclaim policy determines what happened to the PV. There are 2 reclaim policies, retain and delete. In the retain, the PV is not deleted and can be reused later. In the delete policy, the underlying storage is deleted aligned with the PV. What is a storage class in Kubernetes? A storage class is a resource in the Kubernetes that defines how storage can be provisioned dynamically. The provisioner is responsible for creating persistent volumes when requested by application through persistent volume claims. The storage classes automate the creation of the PVs based on the requirements specified in PVCs. You can specify a default storage class that applies to any PVCs. When a PVC does not specify a storage class name, the default storage class is used. Let's take a look at some common storage classes plugins in Kubernetes. NFS storage class, allowing multiple pods to access the same file at the same time, useful for applications needing shared access to the data. Cluster FS, distributed file system that aggregate storage resources, ideal for large-scale application requiring high availability. Longhorn, an open-source distributed block storage system, provides high availability through volume replication across nodes. Ceph, unified open-source storage platform providing object, block, and file storage. Let's create our first PV and PVC. Minikube provide add-on lists, which are pre-packaged components, can be easily enabled or disabled. By running Minikube add-ons list, you can take a look at all of them, and by running Minikube enable with the name of add-ons, you can enable them. I have done that before. By running kubectl get a storage class, you can see here I enable this specific storage class. Now let's create our PV and PVC. In this example, I want to create demo-pv with 1 gig, and after that we have to create our PVC, and here we have to name our storage class, and after that I create my pod and mount a specific path, and in volumes I refer to our PVC. Here is demo-pvc. By running kubectl apply, I create PV, PVC, and a pod. By running kubectl get PV, we can see our demo PV, and by running kubectl get PVC, we can see demo-pvc, and here I have a pod. Now if our pods fail, data will be safe. Before finish this session, let's take a look at CRI, CSI, and CNI in Kubernetes. Kubernetes doesn't manage container runtime, container storage, and container network by itself. It provides some interfaces to manage them. CNI is responsible for managing network connectivity for containers. It defines how network interfaces are configured for pods and how they communicate with each other. Popular CNI plugins include Calico, Flannel, Weave, Cilium. Each of them offer different features. CRI allows Kubernetes to interact with different containers. When a pod is scheduled, the kubelet sends command to the container runtime through the CRI. This includes pulling images from registries and managing container states. Popular CRI tools are CRI-CTL, Containerd, Kata Container, CRI, or runC. CSI. CSI provides a way for Kubernetes to manage storage volumes. It allows external storage providers to integrate with Kubernetes. CSI is widely used for integrating various storage solutions. Popular CSI drivers in Kubernetes are Ceph, OpenEBS, Longhorn, GlusterFS. In summary, CNI manages networking for pods, CRI handles container lifecycle, and CSI enable integration of storage solutions within Kubernetes. I hope you enjoyed this video. Let me know if you have any questions.